Good afternoon. Our lecture for this afternoon would be on rates and ratio. The simplest and most frequently performed measure in epidemiology is count. It simply signifies the number of cases of a disease or other health phenomenon being studied. It is useful for allocation of health resources, but it has limited usefulness for epidemiologic purposes without knowing the size of the source population. So for definitions, rates and ratios are indicators of certain events in health development: level of living, vital events, occurrence of disease, and disability. So every indicator has a meaning or significance. So rate is a proportion with the specification of time. This is a measured probability of occurrence of some particular event. So it is usually expressed as A over A plus B times K. So A is the number of times an event occurs. B is the number of times an event might occur but did not. A plus B is the number of persons exposed to the risk of the event, and K is a round number to make the numerator larger than 1 and therefore easier to discuss. Rate is a proportion in which time forms a part of the denominator. Epidemiologic rates contain the following. It contains a defined time interval, the number of events occurring in the time interval, estimation of the population at risk in the time interval, and a multiplier. Ratio is a relationship between two numbers. So it is an expression of the relative frequency of occurrence of an event compared to some other event. So it is expressed as A over B times K, wherein A is the number of event, persons having one or more specified attribute. B is the number of events, persons having one or more specified, which is different from A. K could be 1 or any whole number to make the number more than 1. So ratio is a fraction but without a specified relationship between the numerator and denominator. Proportion, on the other hand, is a special kind of ratio wherein the numerator is part of the denominator and where K is 100. Rate differs from ratio and proportion in that rate specifies a period of time in which the event occurs. So rate is similar to proportion in that the numerator is included in the denominator. This is often expressed as a percentage. So in epidemiology, proportions tell us the fraction of the population that is affected, such that A over A plus B is usually our proportion. In epidemiology, the occurrence of a disease or condition can be measured using rates and proportion. Rates tell us how fast the disease is occurring in a population, whereas proportions tell us what fraction of the population is affected. So for morbidity, this is the technical term used for sickness and is measured in two ways: prevalence and incidence. So for the rest of your medical career, remember definitions of these two words. Prevalence measures frequency of all current cases of a disease. So it is calculated as the number of new and old cases within a period over the mid-year population times 100. There's a point prevalence, which measures the frequency of all current events at a given instant in time, and the period prevalence measures the frequency of all current events for a prescribed period of time. So you will think, what are the reasons for a disease to have a high or low prevalence rate? High, it could be high risk or a prolonged survival without cure, or low if it's a low-risk disease or a rapidly fatal disease or a disease which has a rapid cure. Incidence, on the other hand, measures the frequency of new cases of the disease. It's always calculated for a given period of time. Formula of which would be number of new cases during a time period over the population at risk. Attack rate is an incidence rate calculated for a specific disease for a limited period of time during an epidemic. It describes diseases or events that affect a larger proportion of the population than the conventional incidence rate. This is used when new cases rapidly occur over a short period of time in a well-defined population. So these are your rates used in demography. Crude death rate, so it's the number of deaths over the mid-year population times 1,000. Cause-specific death rate, it's your number of deaths due to a specific cause over the mid-year population times 100,000. Proportionate mortality rate, this is your number of deaths due to a specific cause over total deaths times 100. Infant mortality rate, number of deaths below 1 year of age over total number of live births times 1,000. Neonatal mortality rate would be the number of deaths in a year of children less than 28 days of age over the number of live births in the same year times 1,000. Fetal death rate is number of deaths during the year and number of live births in same year times 1,000. Perinatal mortality rate would be the number of stillbirths plus number of deaths to infants under 7 days of age over the number of stillbirths plus number of live births times 1,000. Maternal mortality rate would be the number of pregnancy-related deaths over total number of live births in the same year times 1,000. Case fatality rate would be the number of deaths due to a particular cause over the number of cases minus same cause times 100. Crude birth rate is the total number of live births over the mid-year population times 1,000. General fertility rate is calculated as the total number of live births over mid-year population of women aged 15 to 44 years of age times 1,000. So there are adjusted rates to standardize rates. So these are summary rates for the total population, but they are fictitious rates. So these are statistical techniques used to calculate summary rates for populations differing in some important characteristics, the most important of which is age. Thus, adjusted rates equalize the differences in the population at risk so that the rates are comparable. However, adjusted rates are difficult to calculate because the demographic composition of the population must be known. So, crude versus age-adjusted rates. Age-adjusted rates are most frequently used to compare mortality in different populations. The crude rate of an outcome is calculated without any restrictions such as age or sex, or who is counted in the numerator or the denominator. This is limited over subgroups because of some confounding influences. So you could use the direct method, which calculates the rate that would have been observed if the populations being compared have the same age distribution. To perform this calculation, the age-specific rates in the population being compared must be known. So a standard population from elsewhere must be borrowed and can be a composite of all populations being compared or a standard population. Multiply the known age-specific rate times the chosen standard population in that age group to determine the number of events that would have occurred. So the total number of events divided by the standard population chosen is the adjusted rate. If it's indirect, it calculates the number of events that would have been observed in the two populations being compared had the same age-specific rates. So indirect method is used when the age-specific rates are unknown, as in developing countries or unstable because of small numbers in the population being studied. To perform this calculation, the age composition of the populations being compared and the total number of observed events in each population must be known. So age-specific rates from a larger population with more stable rates, or a standard population on the average age-specific rates must be borrowed. So we multiply the known population in a specific age group times the borrowed specific rate to determine the expected number of events that would have occurred in that age group. So calculate the standardized ratio, which is defined as the total observed events in a population divided by the total expected events in that population times 100. If the SR is over 100, it means that more events are occurring in the population than expected. If the SR is less than 100, it means that fewer events are occurring than expected. So when mortality or morbidity is being compared, the SR is called the standardized mortality or morbidity ratio. So for your activity, so this is the given following vital statistical data obtained for a country for 2012. So given this data, determine the following. So please show your computation. The risk of dying for 2012, state of health of unborn children, state of health of infants, the risk of dying in the first 4 weeks of life, the adequacy and accessibility of the health facilities, the reproductive capacity of the country, growth rate. And this one, so for a population of CTZ is 20,000 at the time, answer the following. So please show your computations as well, which has a higher risk of dying between tetanus and gastroenteritis, which has a higher killing power between tetanus and cholera, and which has a higher magnitude of death between pulmonary disease and gastroenteritis, and what is the risk of dying from all causes. So submit this at the end of the session.